Do you work with or around machines or use power tools? If so, you would probably think twice about wearing loose clothing in your workplace, including shoes that pose a trip hazard or lanyards and other objects hanging around your neck. In your line of work, what type of clothing you put on and how well it fits might make the difference between dismemberment or even death. The utility of power tools and equipment, whether electrical, pneumatic, hydraulic, or any other method of mechanical powering, comes with a slew of dangers for their operators. Machine safeguarding requirements are in place to give operators their best chance at safe use. Both administrative control measures that govern how equipment is used, maintained, or otherwise interacted with, as well as engineering control measures that seek to remove or separate employees from hazards, are important in machine safeguarding. As we just discussed, you have some control over your safety in your choice of clothing each workday. But your safety is more than a matter of clothing choice. Hazard awareness, well-maintained equipment guards, and other safety devices and practices play a huge part in keeping you and your coworkers safe on the job. In this training, you'll learn to identify common machine hazards and the types of safeguards that should be employed to protect against those hazards. We will also explore how the proper use of personal protective equipment can act as your last line of defense against the dangers of machine use. This training will also help you build your understanding of how equipment maintenance, repair practices, machine stability precautions, proper tool use and guarding, and other safe work practices tie into machine safeguarding requirements. Before operating any piece of equipment, all potential health risks should be understood and accounted for. This is part of a standard Job Hazard Analysis, or JHA, process. Machine guarding involves protecting workers from hazards at what is called the point of operation. These hazards can include nip points, rotating parts, and flying chips or sparks. Depending on the circumstances, other hazards such as noxious fumes, danger from falling objects, or equipment tip-overs and proximity to other equipment might also come into play. According to OSHA statistics, approximately 18,000 employees who work with machinery experience amputations, crushing injuries, abrasions, and lacerations annually. These can result in permanent disability. Add to that over 800 deaths each year, and machine operation becomes a deadly serious business. Think about the tools and equipment you work with or around. Are you at risk of amputations, pinch points, having loose clothing pulled into moving parts, or exposure to flying materials or sparks? Examples of machines you might encounter that typically require point of operation guarding include cutters and shears, robotics and other automation equipment, power presses and forming rolls, belt, chain, or shaft-driven equipment, milling machines, power saws and portable power tools, and even conveyor belts, which are used to transport materials from one location to another. The exact nature and severity of an injury a machine might cause you depends on the circumstances. Besides amputations and other serious crushing injuries, burns and blindness are also common, and highly traumatic injuries. As a team, workers and supervisors should review the dangers associated with any tools and equipment. If it involves moving parts, sharp edges or material burns, hot surfaces, or any processes or component that might cause injury, it should be safeguarded. Basically, any process that involves spinning, shearing, bending, oscillations, or reciprocation, side-to-side motions, cutting, or punching. Watch out. A safeguard or system of guards should be in place. These typically are witnessed at the side of a power transmission device, such as a flywheel, pulley, belt, connecting rod, chain, crank, gears, and other mechanical components, where energy is transmitted during operation. Along with these equipment-related hazards, never forget that the infamous Fatal 4 may be lurking, depending on the nature of your workspace and machinery or tools. These include falls along with slips and trips, the potential to be struck by objects, electrocutions, and being caught in or between objects. The different types of machine guarding devices are designed with these in mind as well, but safe work practices and an awareness of these hazards have no substitute. So what exactly is a safeguard, and what are some examples? A safeguard is any process that prevents against contact between an operator's body, including their clothing and PPE, and moving mechanical parts or materials. A basic example would be a guard over the blade of a table saw. This both protects against the entry of a body part into the path of the rotating blade and also protects against flying sawdust, wood chips, sparks, and other debris. The table saw scenario is just one example of a safeguard. Guards come in many different types to meet the various requirements for equipment and workplace layouts. They might be fixed in place, movable, or adjustable, or even interlocked where the interlock devices are used in tandem with barrier guards. Interlocks are setups where two functions or mechanisms are mutually dependent on the other in order to operate. Guards might not only include just physical barriers, often they're integrated safety switches, as in the case of two-hand tripping devices, known ominously as dead man switches, or electronic safety devices like optical sensors to shut down a machine or prevent it from starting up if a person or other object is within certain space. Common switches include devices to sense whether a gate or cover is closed before energizing a circuit. For example, where a crush hazard exists, an electronic interlock device might be integrated into a door panel, only allowing operation when the door is properly shut. Interlocks are commonly employed in operations involving revolving drums, barrels, and other containers. As a general rule, restarting equipment should require some deliberate action, with all movable or adjustable barriers in the closed or starting position. These devices can all be bypassed with a little creativity, but defeating safeguards can have deadly consequences. Guards should be affixed directly to each machine wherever possible. They can be secured somewhere else if that's not possible. Clearly, the guard itself should not present a hazard. Common hazards to avoid might include snagging, tripping, or requiring workers to duck down to do their work. There are often published standards for specific machine guarding expectations. If a standard does not exist, the basic requirement is to at least prevent an operator from having any part of their body in the danger zone, while the equipment or tool is in operation. Ideally, these machines and equipment will already be equipped with proper guards and safeties. Any tooling changes in personnel or operating method, addition or removal of auxiliary equipment, machine or system modifications, part configuration, or adjustment in safeguarding design or placement may affect safeguarding. Be ready to adjust the safeguarding or add supplemental safeguarding in the event of alterations in the operating program or related considerations. Any adjustments of safeguards, such as movable barrier devices or electronic interlocks, must be performed by authorized personnel only. Do you know where and what type of guards are in place for the equipment and tools you work with? Could you tell if they were functioning properly? Whom would you ask for assistance or maintenance? It's important for you to know the answers to these questions. If you don't know, find out. There are several general rules for safeguards. Some we already discussed, which are that safeguards should prevent contact between the equipment and body parts or clothing, and that safeguards must also not create a new hazard. If the guard presents a new hazard, such as a jagged edge or shear point, or obstruction of an operator's line of sight, it defeats the purpose of machine guarding. In addition, safeguards must stay secure and not be easily tampered with or removed. To help prevent tampering, there are often extra steps designed into the removal process, and the components are made of higher quality materials. They should also prevent objects from falling into machinery and moving parts. Safeguards need to be designed in a way that allows for safe maintenance. For example, lubrication and machine inspection ideally can be completed without needing to remove the guards. They must also create no interference in operation. If a safeguard prevents operators from doing their job as efficiently or quickly as with it removed, this encourages workers to bypass the safeguards. Depending on the exact nature of your work, specific regulations may apply. For instance, the requirements for guarding exposed fan blades that are less than 7 feet above the floor or working level are very specific. Guard openings can be no longer than half an inch. Highly specific regulations may exist for your workspace. Be sure to identify all hazards that are unique to your tasks and then ensure you're aware of and in compliance with all requirements. A good place to start is the equipment manufacturer or distributor. The hazards that are specific to your work will determine the type of personal protective equipment or PPE you must use. For example, highly reflective surfaces and the use of lasers or production of high-intensity light, as in the case of welding processes, might dramatically change the type of eye and face protection employed. PPE is important, but it is a worker's last line of defense against a hazard. Each employee is responsible for avoiding known hazards and must never attempt to bypass safeguarding. It's better to have to replace a glove due to age or regular wear versus because it was yanked off or sliced open by a machine part. For additional training on PPE selection and use, check out our other safety titles. New employees or operators who have been away for an extended period or who are learning to work on new machinery should especially be given training on PPE, emergency response, conducting a job hazard analysis, and other safe work practices. Employers are responsible for providing proper PPE and replacing it when necessary. Take a look around at the equipment you work with. Is it new? Probably not. Everything wears down over time. Maintenance and replacement schedules of these wear parts is needed to keep guards and other equipment components operating correctly. Imagine hitting an emergency stop button for a conveyor belt and it takes twice as long to stop moving stock as it did when it was brand new. Yeah, that's a problem. Machine and tool guards should be replaced when they're no longer safe to use. You can determine this through daily visual inspections and implementation of a preventative maintenance and replacement schedule. All guards require regular maintenance and tightening to be kept in safe operating condition. Far too often, employees habitually defeat machine guards because they believe it makes work easier or more efficient. Well, there's nothing efficient about having body parts amputated or crushed due to improperly guarded equipment. A basic factor in safe equipment operation is the presence of a kill switch. OSHA dictates that a mechanical or electrical power control shall be provided on each machine to make it possible for the operator to cut off the power from each machine without leaving their position at the point of operation. Oftentimes, these switches build up grime or are obscured or even just forgotten. They can even fail. So, it's important that these controls are tested regularly, replaced when necessary, and that all operators, supervisors, and personnel who work nearby are aware of them and any auxiliary methods of de-energizing the equipment. By their nature, machines include moving parts. This movement causes vibration and changes in the equipment's balance and center of mass. Often, vibrations are engineered out through the use of springs and energy-absorbing materials in the equipment design. But these are never perfect, and their effectiveness drifts over time. Vibrations can cause equipment to literally walk out of its normal space, which can wreak havoc in an industry where equipment placement is directly related to safety. These vibrations can also lead to equipment toppling over, or tools and materials falling off of attached shelves. This is why machines that are designed for a fixed location must be securely anchored. Anchoring might involve bolting the equipment down to the floor or even attaching it to the wall. If you work with equipment that's fixed in place, have you ever noticed any anchoring methods? Other considerations with machine and tool safety include identifying hazards from repetitive motions, travel or toppling over of equipment, tools that can cause continuous or severe vibrations, exposure to contaminants from tool and equipment use, electrical hazards, and so forth. You, your coworkers, and your employer should continuously work together to identify safe work practices and ways to minimize risk to yourself and others in your work environment. Remember, if a hazard can be identified, the potential incident can be predicted. And if an incident can be predicted, you can guard against injury or illness and be ready for emergency response. Successfully navigating your work environment and keeping others safe in the process also involves a strong situational awareness. Situational awareness is when you understand the interaction of people and equipment in a given environment. It is this lack of situational awareness that often leads to equipment damage and, of course, workplace injuries and fatalities. To aid with situational awareness, safeguards are sometimes in place that provide a recognizable sound or light signal of impending or present hazards. These are known as awareness signals, and they are employed side by side with proper hazard communication signage, labels, and tags. One commonly applied safeguarding aid is the use of automated feeding and ejection methods. For example, in a lumber mill, instead of loading materials manually, operators can avoid exposure to the points of operation through the use of mechanized cranes and other stock handling devices. These can be automated using robotics, shifting the human factor away from typical loading and material movement hazards. This same practice applies to the movements of cylinders and other containers, emptying of drip pans, and waste stock removal. In addition to what you've learned here, the OSHA.gov website houses resources that offer expanded hazard recognition tips and safeguarding strategies. As you build out or revisit hazard response programs specific to your place of work, be sure to explore how your industry peers have established safe and compliant work environments. The safeguarding industry is always evolving, so keep in touch with your equipment supplier on safeguarding practices as your equipment ages or requires repair. Take a walk through your area or equipment storage facility. What safeguards are in place? Think about what hazards you or your employees risk when operating that machinery or those tools. Is everything in place to protect you during operation? Related trainings are available to take your team to the next level in safe equipment and tool operation. Lockout Tagout is a great place to start, along with the safety preparation and emergency response topics referenced throughout this machine guarding training. Throughout this training, you were asked to relate safety and machine guarding techniques to your own work environment. We identified common hazards from equipment operation, types of safeguards and the requirements, personal protective equipment, maintenance and repair, and many other considerations that apply to typical machine safeguarding scenarios. Safety is engineered into well-designed machinery. However, proper operation, maintenance, and awareness of equipment hazards depend on the safety culture of your workplace. You play a key part in your own safety and that of your coworkers. If you have a concern, speak up. Whether you're a supervisor or a frontline worker, you have both the right and the responsibility to point out safety issues.